Okay, so I think that this is recording. Yeah, okay, so this is recording. I'm happy to digitally get to present this with you. I'm presenting the paper, What Makes Relational Reasoning Smart by Megan Bullock, which is one of Professor Ofer's students and Professor Ofer. And so this is about the perceptual relational shift that happens in the development of generalization for kids. And so we'll start the slideshow. Okay. So what's the debate about generalization? The ability to generalize over two types of similarity is what it concerns. There's perceptual similarity. So this is like the sharks are fish because they look like other fish. Then there's relational similarity. So that when you are thinking about how things are related to one another, so this is like being able to recognize the mother, father, and child in different things. So both in animals maybe, or even if there's something bigger and smaller, those are have a similar relation to mother, father, and child. So ability to generalize over both types has been observed in animals and human infants. So we know that human infants have the ability to generalize over both types of similarity. The question that everyone's concerned with in this debate is, can infants or young children ignore perceptual similarities in order to make more accurate generalizations over the relational similarity? So that's what this study is thinking about. So the traditional view is that generalization in children moves from perception focused to more relational generalization. So that there's like a switch that happens at some point where people are thinking about, children are thinking about perception focused generalizations, and then a light switch goes off and they are able to think in more relational terms. But Bullock and Ofer propose an alternative view that they call Q validity. So instead of perceptual bias, children, they kind of say have a predictive bias. They're thinking that children are concerned with what kind of generalization brings the best predictions about the target that they're thinking about. And so they devised a couple of experiments to kind of think about this. But before we get to that, there are some reasons, according to the literature, that Bullock and Ofer offer for this alternative view. So first, Siegler's balance scale problems. Children get better at encoding relevant information as they get older, and there's not and similarly, Piaget studies showed young children have the tendency to give attention to dominant dimension when there are competing dimensions for perceptual similarity. So the idea is that these things they don't happen like they're graded more, and so they suggest Bullock and Ofer suggests that the results of Siegler and Piaget make sense, even though Piaget is like these things are like qualitatively different from stage to stage. That both Siegler and Piaget can be explained by saying that as children grow older, they acquire sensitivity to context and its ability to dictate appropriate dimensions. So this is the view of Q validity. And the idea being that as children get older, they start to pay more attention to the appropriate things to make correct decisions about generalizations. So they did a couple of experiments around these perceptually identical problems. So there's the offspring problem and then the prey problem. And so we've seen the offspring problem before, that you give them two sets of adults, they have different offspring, And then in the test, that you have them think about what two parents, what their offspring will look like. Or like I think in the experiment, they don't actually ask them, like, they just ask, like, does this make sense? The prey problem is kind of exactly the same, except for instead of being connected in a biological way, that the offspring thing is the juvenile bug is now the prey of the predator adult insects. So in the first experiment, so they have these participants. They do undergrads as like adults, but then they are primarily focused on the 5-year-olds, the 4-year-olds, and the 3-year-olds. And the stimuli, so people on a computer screen, they're presented with illustrations of juvenile and adult insects on a computer screen. There's a relative similarity of adults was never equal to that of the juveniles. So and if we go back here, that like the adults don't look, whereas the juveniles like kind of look similar. The adults don't very much at all look similar. The procedure is that participants received either offspring or prey problems in which they were presented with juvenile A, adults X, juvenile B, adults Y, and then adults T and juvenile T. And then they were asked 3 questions. The categorization question: is juvenile T the same kind as juvenile A or B? Projection: will juvenile T look the same as juvenile A or B in the future? And then induction: does juvenile T have a property, Golgi, inside its blood similar to juvenile A or B? So they're trying to see how children or participants were thinking about this new test juvenile. So the experiment 1 results showed that the kind of what they expected to happen. That the adults, they had a very easy time with both the offspring problems and the prey problems. That for them it was easy to think about relationally matched with the offspring problem, but not the prey problem. For the 5-year-olds, it was a bit trickier. So the 5-year-olds are getting the offspring problems for the most part, but the prey problems, they haven't figured out yet that like the prey problem is not a relational match the same way that the offspring problem is. And then it just gets more complicated for 4-year-olds and 3-year-olds, that the 4-year-olds and 3-year-olds, the 3-year-olds especially, are not even really, they're not sure that the relational match works even for offspring. But then as they figure that out, they think that the same thing applies to the offspring or the prey problem. So the second experiment is, so if you have those results, but we know that maybe the difference with the 4 and 5-year-olds is that like more learning has happened that has enabled them to figure out that offspring is a relational problem, but prey is not. So the hypothesis is that 3-year-olds would begin to recognize the prey-predator relation, and they wouldn't predict, they would begin to recognize the prey-predator relation, wouldn't predict category membership. So they reran the experiment and giving feedback to 3-year-olds for them to learn. So they did both. They redid the experiment, and then they also gave them feedback as they were doing the experiment. So they would, if the participant got it right, they would say, yes, that is because of this. If they got it wrong, they would say, no, it's this. And so they did the same 3 trials, and then they tested them again 2 days later to investigate retention to see if the participants actually learned the material. and they learned this relation. So the experiment 2 results showed that 3-year-olds did show growth in ignoring relational matches in the prey problem. This improvement was retained even after 2 days. So they get, you can see in this graph, they get progressively better, that they get better at both the offspring problems and the prey problems. Okay, so the how we're thinking about the discussion here is how they think about the discussion in the paper is that the experiments don't provide support for universal perceptual relational shift in generalizing. So it doesn't work all the time. There are times when it's necessary to use perceptual generalization as opposed to relational generalization. And this is why adults, for instance, are better at the prey problem than kids are, because they know that the relational form of generalization is not effective there. And this study shows that children do show a growing sensitivity to this sort of reasoning. They think about what are the reliable predictors of novel properties. And so the only failures that happen are failures that have to do with lack of knowledge of reliable predictors. So now once children know what reliably predicts the thing, that's what they want to use, is what this study says. So they entertain this objection. They say, well, maybe that this wasn't as dramatic a shift as you would expect to see from perceptual to relational generalization. And they kind of explain this by saying that the children, the participants, were coming into this study already with knowledge of the offspring relation, and so that makes it seem that because they already had that knowledge, that you're not going to see this dramatic like button going on, light switch moving on them from perceptual generalization to relational generalization. They also talk about cognitive architectures that are developed to kind of model this, and so there's one that can recognize relations just from observation, and they say that's a promising one for modeling how humans come about to this kind of change that's moving from perceptualization generalization to relational generalization. That's learning relations through observation. And so they say that that's a promising place to look. That's all I have. I wonder if there's any questions. I look forward to hearing what your thoughts are.